We have a great reception.
So, I found out that just quick review the slides, not well, whatever, all that stuff. Area status, we have no changes, right? That is the only thing.
Yeah, I think that's it.
Okay, so I found out that we also got some SFC work.
Cool.
I don't know if you sure, but
Yeah, that's good.
the statement, this, and I put that there. I saw the email that Harry sent out.
Yeah, and I booked
Didn't
it.
see any answers.
I know.
Yeah.
It's good that you can do it. That's a good idea.
Yeah, I think so too. I call attention.
Well, they have a and so people hear it from the participate in IETF work. So we're ready to chat as opposed to talking about sponsorship because that's money.
So, right, so you're going to introduce that.
Yeah.
And what do you want to talk about? Statements or not? Statements. I can.
Oh, actually, I have to remove this. I'm
happy to help you, but I'm perfectly happy for you.
Thank you.
You have practice now.
No, that's a little harsh. I mean, yes, he does have practice.
Hello. Come on. Hello. Hello. Hi. Thank you. Good afternoon. I know it's after lunch, but this is the most exciting meeting of the week. Yes, everything goes downhill after this. So this is the routing area open meeting. Aaliyah, Deborah, and me, Alvaro. So as always, please note well, when you download these slides, you can not only read all the details that talk about here, but you can also look at some of the other resources that are related to the routing area. As you have seen in other working groups as well, please review documents, participate in the process, help all of us make the product not just of the routing area, but of everything better by having more reviews in the different stages of the working groups. This is the agenda for today. If anyone has any bashing to do, please do it now. Nope. So we're going to have the first 15 minutes, the normal administrivia. Then we're going to have Heather Kursky from Open NFB, I guess, what we call it, give an overview. Jeff is going to talk about standard action registries. Then we're going to have the winner of one of the winners of this year's Advanced Networking Research Prize talk about his work, which is related to routing. Then we're going to have the normal working group reports with a routing area directorate report as well. And hopefully we'll have about 10 minutes at the end to talk about anything else anyone wants to talk about. Okay, so the status of the area, not much has changed in terms of working groups, new working groups are closed or anything that we rechartered since the last IETF. We do have 2 new working group chairs. Joel Halpern recently took over as co-chair of SFC. Yes, Lois pointing to Nick. Nick has been, we pointed him out, I think, in the last IETF. Nick Lehman is one of the new chair in replacing Ross Callan in MPLS. And Martin Vigoro, who is the new chair of Spring. As all of you guys know, before the IETF, we have an IETF hackathon. I'm very happy to say that there was a lot of work related to routing and the routing area in the hackathon, and even happier to report that we had 2 winners related to the routing area. The best input to a working group, which the ACTN team won. I couldn't list everyone, but we have a picture of the team down there. If you're here, can you wave, say hello? Okay, right here at the front. Yeah, very good job. And we also got the best, well, not we, but there was a team related to the routing area that got the best new work to the IETF, SFC team, and the service function dev kit team. Is anyone from that team here? They're probably working hard on making it even better. So that's very good. We're very, very happy to see work related to the routing area in the hackathon, open source work, of course, and the fact that we are implementing our protocols. Remember, the IETF is about running code. So let's keep this up. So there's a couple of things that we want to talk about besides the normal events trivia. There's a couple of statements that have gone out that have been published. About a week ago, the IAB published a statement on IPv6. The IAB is the Internet Architecture Board. You can follow the link down there. I highlighted some things here. Basically, what the IAB says is it expects that the IETF will start requiring IPv4 compatibility for new or extended protocols. In other words, the IAB is trying to talk not just to the IETF, but other SDOs about the importance of prioritizing IPv6 work. You can go read more of the details here. They talk about, of course, the need to maintain critical infrastructure with IPv4, of solving security problems if there are any, et cetera. So this doesn't mean abandon IPv4 or anything like that. It means prioritize IPv6. Now, if you read the statement, they're talking to the IETF and other SDOs. This is because the IAB is not the body that tells the IETF what to do. The IETF, all of us, decide what we're going to do. So what I want to ask you to pay attention to is this draft in the Sunset 4 working group. So this draft is sort of the follow-on to the IAB statement, where it talks about, it's called IETF and work on IPv4, and it talks about what the initial proposal for what the IETF should do is. As you can notice from the name, it is still an individual submission. It may, of course, or not, be accepted as a working group draft, and it may go through the process and become the IETF consensus document. So the question of what will the IETF do regarding IPv6 or IPv4 might be reflected, or should be, if this is the consensus document, reflected in this document. Please read it. If you have concerns, if you have better ideas on what to do, or just don't like what it says, or you like it, please go to Sunset 4 and participate in the process. Among other things, it talks about, it says the IETF needs to continue to update IPv4 only protocols for vital operation or security enhancements. There might be activities related to transition or decommissioning, so all geared towards getting rid of IPv4. It talks about things like the ASG review charters or proposed work, so that we can work without IPv4, except in cases of security transition or decommissioning. Now, this is a proposal. This is not what the IETF is going to do, unless it becomes, the IETF consensus. So, because this is all based on consensus, please go to Sunset 4, comment on the list, whether you like this or not. So, just want to raise awareness of work that is going on around the IETF. Yes.
Okay, I can just speak really loud. There we go. So Dave Senecrope Erickson, but speaking in capacity of a broadband forum IETF liaison manager. Did the IAB say anything about how they were going to communicate this out to the greater community? This will come as quite some news.
Well, honestly, not that I know. I'm assuming that because the IAB manages the liaison program, that there will be something there. I have no idea. But if you're asking,
So I
because
should
you're the
ask
liaison
myself.
anyways,
Yeah.
I don't know. I would ask you whether you know.
I haven't seen anything. That's why I'm asking you. Okay. Okay.
So it was issued as an IAB statement. There's a blog about it. There's, I think, some press. Greg would probably know what kind of press they're doing.
Right. Yeah. And it would be the press that I'd probably, in my capacity, want to head off.
Just to Dave's point or question, I myself took the action of distributing this to the ONF membership and leadership, so to bring it to their attention.
Thank you.
So the thing that worries me with this whole space is that there's an awful lot of IPv4 stuff out there. There's an awful lot of stuff that will never support anything but IPv4 out there. And if the IETF doesn't properly support it until true end of life, someone else will. And some of it could be regarded as national infrastructure. So we could see our friends in the ITU, for example, legitimately take up developing IPv4 unless we sort of look after this until its true death.
Completely agree with you, Stuart. Again, please contribute to the document. And this is, again, the initial proposal. This may not be the document that goes forward as consensus of anything, right? But it may be because it's the only proposal out there. So please contribute if you have any thoughts or comments or anything. Okay, so this statement went out a couple of weeks ago, or maybe about a week and a half ago or so. Today, about an hour and a half or 2 hours ago, the IESG put out a statement, completely unrelated statement on something else. This one is called IESG Statement on Charter Development, and it talks about support documents in the IETF. Support documents are things like use cases, problem statements, things along those lines. Support documentation that is important for the development of solutions in the IETF, that is important for the working groups to agree on what is going to be solved, right? What's the problem, what is going to happen. There are a couple of things here that the IESG encourages, but beyond saying that these documents are of course important. It says it encourages the community to consider alternate mechanisms of publishing. In other words, there's no expectation that we're going to have a waterfall type model where use cases, requirements, etc., have to be published before solutions. And not necessarily in the routing area, but in other areas, we've seen cases where work sometimes may get delayed because of trying to process and make use case documents perfect. There are many, many valid reasons for publishing support documentation, and this statement is not saying that we shouldn't publish any of this. All this statement is saying is really what the sort of the last part talks about, which is that the working groups, as we are rechartering or chartering new work, should consider from the start the end publication state of any documentation. So that we're not at the IAG publication state, for example, talking about whether we should publish or not a document. This just means that. It means support documentation is important. Consider what's going to happen with it during the work process, the work cycle, and during the life of that document. Comments, thoughts? Okay. I didn't put a link here because I did the slides before the statement went out, but if you look at your email, it should be in there from about an hour and a half or 2 hours ago. Last time, at the last IETF, we started an informal open source get-together. We want to try and continue that. We sort of recruited Hari, you can see his email down there, to help us organize some of this. We have a room for Thursday morning at 8 a.m., Park Ballroom 3. Last time we had initial discussions, what are people working on, et cetera. Hari has sent some email on the open source list, which you can also see there. You can subscribe. If you're interested, please come by. There's no food, so please, if you need breakfast, bring your coffee, bring whatever you want to eat. And if you want to bring something for me, that's even better.
We like coffee.
Yes, coffee is good. Yes. Okay. So just as a reminder, this is who of us three is responsible for each of the working groups. Hopefully all the chairs know this, but in case you need a reminder, here it is. Okay, so now we're going to start our regular scheduled programming.
You have her slides?
Yes.
Okay, today we have Heather here. She's the director at OPNFV. And as some of you may have known, this past Friday, they had actually an open meeting that for IETF people that they could participate. And so some of you may have been there. Since they are here this week and they are supporting quite a bit of IETF work, we thought it would be a good idea in routing work that she would come and give us an introduction to OPNFV. And so here she is, Heather.
Make this for short people. All right, there we go. All right. Well, all right. Hey, everybody. I am Heather Kirksey. I head up the OPNFV project, which is part of the Linux Foundation. So if y'all follow sort of the world of open source right now, the Linux Foundation over the past couple years has been spending a great deal of effort in sort of, taking what they learned from the Linux kernel community and sort of commissioning and helping other groups get started with other sort of open source foundations and open source projects that they might want to host. And one of the biggest areas for the Linux Foundation recently has been around networking. So it's been pretty exciting, and I sort of head up one of those organizations. And there are a lot of them in the space. And here's sort of a kind of non-exhaustive, but kind of set of various projects and foundations that are addressing sort of different parts of the stack around sort of NFV, SDN, cloud, and sort of just general, kind of networking work and network transformation work in the open source space. Many of them are part of the Linux Foundation. There are a few that are not. ONOS is essentially going to become part of the Linux Foundation. Is sort of a little bit quasi, and OpenStack is its own thing, and Open Compute Project is its own thing. But all the other things on here are sort of affiliated with the LF, which is really cool because it means that there's a lot of innovation and a lot of work going on in open source, really focused on next generation networks. But it also gets a little complicated because there are a lot of groups out there addressing very specific parts of the stack. Some of them, like OpenStack, tend to have come from more of sort of an enterprise kind of cloud services mindset. So understanding networking use cases, service provider use cases, telecommunications use cases has been sort of a new thing for them. And so what that has led to, sort of when OPNFV started, is a lot of folks basically were looking at NFV and saying, we'd like to do this, we'd like to do it in an open source way. We think a lot of the pieces are out there, but they're not necessarily well suited to telecom or service provider or NFV use cases. And we don't know exactly how they fit together to make a platform. So they started OPNFV about 2 years ago. And we are an interesting open source project because basically we are systems integration as an open source effort, which is a little bit different than most of the projects out there. So what that practically means is basically there are a lot of things out there. We sort of compose a stack around the virtualization and control of compute storage networking. And then you've got your applications and management and orchestration, OAM type stuff on top of that. And then we have a number of activities that we do around deployment, testing, and new feature development. What that practically means, I'll put a little bit more sort of detail on that, or sort of tangible information, is that we end up integrating projects like OpenStack, Ceph, various SDN controller projects out there like Open Daylight. We have work going on the data plane. We work with groups like, all right. We work with groups like FDIO on VPP, groups like DPDK, OVS, and all those things. And basically sort of compose all those things together to create different flavors of OPNFV platform. And so how does that end up sort of practically working? We sort of basically go through a set of sort of tasks. Basically, we have what we call scenarios, which are different sort of combinations of deployment or combinations of components that are then sort of tested for kind of specific use cases and needs. So first thing we do is sort of create a set of components. So if you think back to the chart a couple minutes ago, a scenario could be something like OpenStack plus OVS plus ONOS and maybe some other additional OpenStack components that enable fault monitoring better or something like that. Or it could be Open Daylight plus VPP on top of OpenStack that may be also making use of containers. So basically you compose a set of things, we deploy them onto hardware, and then and we have basically a federated community test lab where we've got, I think at this point, 12 operational labs around the world, different hardware vendors, different hardware architectures, and we basically sort of deploy the thing, automate it, and then test it, see what it works, and feed that information back to those various upstream communities. And then where there are feature gaps and things that are missing that are important to the networking world, we take those back up to the upstream and work with them to develop new features within the context of their code. So here's sort of a set of our projects and kind of where they line up in the stack. I won't go into all of this detail because we've got like 40 some odd projects. And I'm just gonna pick on a couple that I think are particularly interesting perhaps to some of y'all here. So first one is the SFC project. And if you were in the SFC meeting yesterday, you actually saw Brady Johnson from Ericsson, who's the PTL of this project within OPNFV, sort of presenting kind of where they are within the context of Open Daylight. But basically, Open Daylight is working very busily to support service function chaining. And then within the context of OPNFV, we are then able to sort of integrate that with all of the other pieces necessary and do sort of use case-based testing. So for example, when we test SFC in the context of OPNFV, we actually lay down an entire NFV platform. We install some sample VNFs, and then we actually will set up function chains and validate that they work. So we're able to exercise that code and actually exercise the capabilities in ways that sort of Open Daylight kind of with their own unit tests isn't able to. And then we're able to sort of get that information back to them. Here is sort of within the context of our releases are named after rivers. So our first release was Arno in Florence. Our second was in Brahmaputra. Our most recent release was Colorado. Danube was coming up. So if you're, why does it say Brahmaputra up here? That is why. And so within the context of Brahmaputra, we could basically, we had basic SFC support using Open Daylight Beryllium. And basically we could just validate that basically two service function VMs are created and do a chain one, chain two, one's blocking HTTP, one's blocking SSH, and validate that that worked. If you sort of want to get into a ton more details, I encourage you to maybe go and look at the presentation that Brady did in the SFC meeting, or come talk to me afterwards. Within Colorado, we made enhancements. We were using Open Daylight Boron, and so we do have support for NSH. So, getting to that sort of IETF and open source working together, we are implementing some of these standards. So we do support NSH. We now support multiple nodes, failover and load balancing, and dynamic service chain modifications. So other OPNFV related projects that are kind of interest, I think, to IETF sort of routing crowd. We've been working quite assiduously on the IPv6 support. In Arno, we didn't really even attempt to touch it in our very first release. In the context of our second release, Brahmaputra, we did our very first IPv6 testing. It was very basic. But in the context of that time frame and heading into Colorado, we also worked quite a bit upstream with OpenStack and with the Linux kernel development team to really get the IPv6 support. And both of those things a lot better than it used to be. And so in the context of Colorado, we actually have a support for full support for IPv6, at least according to sort of the use cases that the folks participating in the project, sort of had identified. Both underlays, overlays, we can deploy in a v6 only environment. That was, and then also we did a lot of work within Open Daylight to get their v6 implementation a lot better. In our first time, we had to actually kind of create a little helper router function to work around Open Daylight limitations. But now Open Daylight, we've worked with them to get that working a lot better too. So we can support a lot of IPv6 stuff now, which is always very exciting. And we can do it in multiple install tools. I hit the wrong button. Okay. All right, a couple other projects. Fast Data Stacks is a project that's integrating VPP into the overall stack. There were, I think, some VPP projects going on during the Hackfest as well. So that's definitely something that we are looking on. And then we also have some work going around on models as well. So using some of the standard models that folks are producing, netconf actually our plan right now, they're doing use case and test blueprint creation. But the idea would be that we can then, having this end-to-end platform, actually start taking some of those standardized models and trying to provision applications with it and sort of see how those sort of standards-based models actually work and give that feedback and try to work fairly agilely and hand in hand with the various organizations that are developing them in different areas. And we've got a couple other projects. SFC project also uses netconf for some of that configuration. And then we've also got some other things using some other sort of modeling capabilities. Some folks are using Tosca, and then also there's a specific kind of modeling stuff within Congress, OpenStack. But so these are all kind of integrated stuff around model stuff, but we are using great work around netconf and Yang that's going on here. And just kind of end with the get involved. We're doing a lot of things I think that are relevant. We're implementing a lot of the RFCs and internet standards that y'all are developing here. And kind of the last thing is, I'm always open to hear more about how sort of the Linux Foundation in general, the Linux Foundation networking projects as a set of projects, or OPNFV can better, have a better relationship, tighter connection, better touch points on collaboration, with all y'all doing the really great work that you're doing on the standardization side, so we can all march forward together. So if you have ideas on sort of how to foster more of that collaboration, like I'd love to see, people who have, in-depth knowledge of the standards interacting with the dev teams. I'd love to see more developers here. I'm, sort of working on that. It's a thing it's a horse I keep flogging within our community, and, ideas that you have to continue to make that happen. I'd love to hear about it. And, definitely feel free to get involved, whether your company's a member or not. It's an open source project, so everyone's welcome to participate in any technical work of the project.
Okay.
Any questions from anyone?
Anybody? Any questions?
Open source is cool, yay!
Hey, thank you very much, Heather, for stopping by. All right.
Jeff, sure. Here you go.
Okay, we'll see if that stays. Afternoon, I'm Jeff Haas. This presentation is being given on code point management. This is a derivative of the topic that I actually present internally, for our coders at Juniper Networks. Partially, this is from anybody who's been doing IETF stuff on a regular basis to very junior engineers. So the key thing here is that this is presented as, early deployment. Stop making customers regret it, simply because our practices and doing them poorly actually make people unhappy, and sometimes they may break the internet. So what's the motivation for the talk? code point allocations do have impact. You guys spend a lot of your time working on PDU formats. A huge portion of that is figuring out what goes into them and how to allocate them. And improper allocation of those, especially when you're to the coding point. Now, obviously, if this is all on paper, it never matters, but the minute it hits something that customers can actually load onto a box, then it becomes important. And some of these issues, depending on your protocol, are local. If they're some sort of protocol mechanism that is point to point, it's never going to matter except between two devices, although this can cause you interop issues on your network. But the bigger problem is we have systems like BGP and DNS that are global, and depending on how the behavior is manifesting, can actually have global impact. So the blast radius of this is really the important problem. Is this something that you're going to see only if impacting a pair of devices, or is this something that's going to prevent a new feature from being able to roll out on the internet? So obviously we need code points to operate. When we're doing a completely brand new protocol, it's really easy. We just start making stuff up. As long as we're not resting on top of something else, we can do whatever we want. That makes it easy. But the minute we start getting things deployed, the maintenance, the janitorial work becomes a critical detail. And a lot of these things require coordination. Obviously, we do registries to do this sort of thing. IANA is the #1 registry that we do most of our work on within the IETF. There are other registries that we do interact with, including, for example, stuff at IEEE. I'm not going to read this. This is from RFC 5226. This is the variety of registration policies that are available to you when you're writing your drafts. The majority of these do not get used. But each of them has a little bit of history, and some of them make no sense depending on exactly which situation you are in. So why are we here? Most of you are probably not developers. Hopefully a good number of you are. But as protocol authors, when it becomes necessary to have somebody write and implement that code, they have to make choices that lets them get their work done. And that work includes writing it, testing it, getting early deployment, and again, not breaking some customer. So your choices do have far-reaching impact, and you have a strong responsibility to do the right thing. What do you do? Well, if you pick one and you're wrong, this is a common strategy that happens when you're just doing something. Registries, stopped at number 29, you're going to just pick number 30. Let's see how that actually behaves. Well, if you happen to grab that and you leak the code out there and somebody else collides with you, minimally features do not interoperate. In some cases that just means that something misbehaves, a pair of boxes for the point-to-point features does not work. If it is, as we are, and one of the motivations for giving this talk at this IETF, we're trying to roll out some brand new BGP features which have global significance. Somebody squatted on a code point and their feature did not deploy. It was globally unusable. Can interoperate? Who wins? And the problem is, when you're publicly squatting, that question mark is really out there, and what do you do about it once those code points become contaminated? That's a problem, especially for code point spaces that have a small number of entries. So in examples of where you're wrong, have a reference to a draft specifically in IDR to take away 1, 2, 3, 4, and there's a couple more in the new draft, code points that had become contaminated because somebody deployed code, squatted on things, and it caused issues. Large communities was the one in question. They got the next number of 30, but turned out that somebody else had actually grabbed 30 and their code leaked out and was in production and caused the large community feature to not be able to be used. What's sort of an interesting point that Suno pointed out to us, code points 30 and 129, which are part of this, originally did get work done in our hackathons that we just got done talking about. So please come hack, but for God's sake, don't deploy that. Now, you have a slightly different issue if you pick one, even if it's something that you're allowed to pick, and you ship it as a pre-RFC feature. And part of the work is you're going to grab something, you're going to make use of it, And if you're really lucky, you've arrived at a stable format before it ships out and globally deploys. But if the format does shift, which happened as an example in BGP using the independent domain feature, path header 128, it was originally deployed and just shy of RFCing with 2-byte BGP aliases. As people do BGP these days, we've gone to a 4-byte system, and they changed the packet format without updating the PDU format. And interactions of this feature caused global outages when it misbehaved. This feature in many cases is now considered toxic for exactly that reason. And first come, first serve is not a guarantee of safety. This means that when you're deploying things, you have to be sure that it's going to continue to interoperate over the longer term. Again, what is your blast radius of doing the wrong thing? So you do have to pick a code point, and most IETF registries do have a number of fairly permissive, especially first come, first serve style policies that allow you to just get one assigned to you. And you want to do this when your feature is far enough along to actually deploy. It's stable. You think that it's not going to be radically shifting. Grab a code point. That's what the registries are there for. And if you're dealing with IANA, IANA's very responsive. They usually get back to you in less than 2 weeks, often in about a week. There's no reason when these exist to not use them. However, we do have more restrictive policies. In some cases, these things make sense. BGP, for example, it's path attribute code space. RFC was done over 20 years ago, had a code point space of 255 bytes, 255 numbers. These things are precious, and you don't want to just burn them for no good reason. And as such, they got one of the more restricted policies. 5226 bis gives us the ability, along with other documents, to get early allocations when we're far enough along. So again, don't use the fact that these things are under restrictive policy to just squat on a point. Work with the chairs to get something allocated to you when it's actually time to deploy something. And the last point is actually important. This is all partially complicated just because RFCs go slow, and development ideally goes faster. So we need to make sure to have good policies that allow us to move at a speed that's closer to development. So this is the place where we start getting into what we tell the developers, but this is important for you as you're writing your specs and figuring out how do you actually make registries for people. What do you do when you actually need a number and until you can get that assignment? Most features these days, not necessarily the older ones, give you some sort of experimental range. In BGP's case, you have exactly one number. One number is not terribly useful, and it's certainly not usable in a globally deployable format. And we're having a different conversation in IDR about this. For those types of experimental numbers, you could use those however you want, but it does mean that internal coordination is required. If you have 3 people trying to use a single code point for testing, they're obviously not going to be able to test stuff in the same software load. You have to figure out something else to do. And even if you do sit in one thing, you do have to have some way to handle the migration scenarios. You're going to pick a number. The number is going to be expected to change. The implication is that when you're writing the code, when you're developing things, when you're actually doing the registries, have a plan in mind for how migration works, how to go from number A to number B. That's going to be the final thing you ship. And especially for features that allow for some sort of temporary assignments that may be globally deployable, and you eventually move into a final number assigned from the IANA, you want to be able to handle the case that the same feature may be present in more than one place. Most important thing is you cannot ship stuff using these experimental code points. You will collide with somebody else. You will make somebody's network unhappy. Now the problem is, if you can't get a first come, first serve, if you can't get an experimental, you must squat on a code point. That's okay for development purposes, as long as you do not ship it, and as long as you have a migration scenario. The thing that we tend to encourage is, what do you do about the migration life cycle? grab an ideal number. Experimental is a good thing to start with. If you do squat on it, require configuration as part of your early deployment for this thing to go out. This allows you to actually have the feature off by default, pick a number that can move around as the process continues, because if you're not through early allocation yet, that number is not really assigned. If you're thinking 30 is the next one available, what happens if it's 31, 32, etc. And while it's tempting to provide global configuration to change from a default number, defaults almost always are wrong. These are things that hurt us long term, but it leaves us in a very interesting problem, highlighted the bottom item at red. It is dangerous to actually ship these knobs that you may want to use for internal testing purposes.
So I've seen the opposite of that, which is hardware that got shipped with a protocol identifier burnt into it, where there was a strong desire to change that protocol identifier as a result of the standards process. So hardware that's shippable with configuration is a lot safer than hardware that's not shippable with configuration.
I agree, but again, it's sort of the blast radius conversation. So BGP, for example, for path attributes, if you allow people to arbitrarily pick a number to get it to work, and you effectively end up squatting on things, and that leaks outside your network, you've done exactly the thing we're trying to avoid. So I agree. There is a tension here depending on where this is in the life cycle and what the blast radius effects are.
Yes, it's easy to change a piece of software, easy-ish to change a piece of software and send it out. It's millions of dollars and months to change hardware. So please, let's make sure there's no confusion here. Hardware usefully is configurable.
So again, as people working on specs in IETF, what do you put in your protocol spec? Eric Rosen, one of our people currently working for us, previously working at Cisco, has a very libertarian view of things. Make it easy for people to get stuff. You want them to have it as easy as possible, as simple as possible, without fighting for things. And you want to make sure that they can do it without having to squat on something for real. But ideally, that means that you're going to make it easy for them to do as part of how the PDU is built. Be generous with the number of code points when possible. One of the sort of negative things I still see on a regular basis is people trying to squeeze the bits for cases that really don't matter. Is it 1 byte or 2 bytes? Well, if you think that 1 byte's going to last you 20 years, that's fine. Does 2 bytes make your allocation policies easier? That's actually a useful question. Review considerations. We have 2 of them. For code, code points are often scattered across general feature headers. This is what happens part of the normal development process. You end up with litter. What needs to happen, and this is something that as people pushing technologies within your companies should encourage the development process to do, centralize code points, especially ones that are public, IETF, IEEE, etc., into a small number of files, and make sure that those are under a strong review process, perhaps even involving the people in this room, because you're the ones helping people actually navigate the IETF process when you have somebody that's just wanting to implement the code. And as the expert reviewers, you should help them as part of that development process figure out what code points to choose until they can get the real ones. And ideally, if they need early allocation help, give them a hand. If not, talk to the chairs. They'll tell you how easy this actually is. For specs, never create a type field without also keep creating the registry for it. When you're reviewing drafts, and this is ultimately the responsibility of the working group and therefore the chairs, but especially for shepherds, on the exit policy, I know MPLS, I believe, assigns shepherds very early in their process. You want to make sure that the draft is carefully reviewed for the points in there and what policies they need to be. Ideally, stick with something simple. First come, first serve, standards actions. You probably want a couple experimentals thrown in there. Things like private have shown to just generally not be helpful. They're probably not helpful things at this point. 5226 is, as part of its BIS going through those discussions. And we want those points to be owned by the working group as much as possible. Make it easy, to go to somebody to say, hey, IDR, BEST, etc. I need to have a code point. Who do I talk to? IANA says that the registry policy is owned by X organization. If that's your working group, it goes quickly. And you want to avoid policy speed bumps because that causes people to do the wrong things. And this is one of my little pet peeves. For God's sake, if you add a new feature, refer to the features by name. My favorite historical pet peeve is like OSPF. What is a Type 5 LSA versus a Type 7 LSA? They have well-defined meanings. People who are strong protocol geeks know exactly what they are. But what you've done is cemented people in their mind that the code point is the important thing rather than the feature name. And especially as things are going through development, that's a problem. IANA is easy to work with, especially for first come, first serve. Just ask for them. They come quick. And last thing in terms of specifications, the document shepherd work has to include verifying all of the registries before we get up to ISG. John, please.
One thing I don't think I see on there is, and maybe it's because it's too glaringly obvious, but it's when reviewing a document, if somebody's squatting on a code point right there in the document, make them take that out. And that should at a minimum happen at working group adoption time. A document should never become a working group document that's inappropriately referencing a code point. But there's no real need to wait until then. If you notice that, if you see something, say something.
Right. And the related piece of that is even for documents that have not been adopted, we have people doing a lot of development work on pre-adoption stuff. If you see something, say something, tell them to get it out of pre-adopted IETF documents. Donald.
Hi, this SCS or standard action, you mean to have the registry divided into regions with those two policies? Anyway, standards action seems like it's stronger than you need in many cases. I mean,
it is absolutely too
depends.
strong. It is absolutely too strong in most cases. And the only reason you actually need that is if you do have, for some protocol reason, a really small code space, you need to lock it down a little bit.
Yeah, but there are also some other things. I mean, if it's a TLV where the type, things get ignored if the type is unknown, then you can be more liberal. If it's an error code where you might want to take different actions depending on different kinds of errors, and if you get an unknown error, you can't tell what the hell to do, then it has to be stricter. And, it seems like there's a little gray, so like most fill things are IETF review. Seems to work well for us. So, some are others, or expert. Expert is also a good solution, and it's a lot of flexibility, and the expert can compensate if the registry is getting used up to some extent.
Agreed.
Michelle Cotton as the IANA services operator. I just wanted to make one small clarification, which is you mentioned 5226 BEST up there, but the early allocation RFC is 7120. So if for those registries that are standards action or IETF consensus, if you really do need a code point, we've really perfected the early allocation process, and it runs very smoothly now. So if that is needed, use the policy because it's there. And in the process of coming up with the registries in your documents, in those early stages, we're here at the IETF meetings. We have a desk over by registration. You're more than welcome to come over there and ask us what it's like to have first come first served registries versus expert review registries versus all the others. And we're happy to tell you, how they work and what the timing's like. First come first serve registries, we actually strive to get assignments out to people within just a few days. Not at the meetings, you're working on documents in between, just email us at iana@iana.org. And again, we're happy to answer questions. We much prefer to do that way ahead of time before last call, make things right early on. We're here to make the registries useful for you all. So we want to do what's going to work best for the community.
So before you go away, Michelle.
Sure.
So, Stuart Bryan. So one of the things that we have is the 2-year drop dead date for early allocation. And I'm wondering whether that's still a wise thing to have, because I know it was intended to stop people doing it just to grab code points, but sometimes it does take us more than 2 years to finish something for very good reasons. And if Jeff is encouraging people to, go early and you hit a deadline, then I think in practice we just forget about the 2-year rule. But maybe we should do something more formal so that people aren't scared to evoke it.
Your timing is impeccable. Because something that's not covered by 7120 is actually creating early registries, which has been discussed in recent months. So there's a chance I might rev 7120 and we could discuss whether or not the 2 years is too small.
Yes, please, because I've sort of hit the buffers a few times. We've always done the right thing, but it would be nice if we gave people a bit more confidence that we would do the right thing.
In real practice, because Aaliyah has been dealing with early allocations lately, I don't think we've hit the more than 2 years often. I think it's only been maybe once or twice, but ultimately the ISG can say, just let's leave it open for a little bit longer.
I mean, I've definitely had that experience in Pseudowise, so
Yeah.
Yeah, we had one case of an early allocation from OSPF on the segment routing drafts where it was necessary to go to the ISG and request that it be extended. I hear you that sometimes documents take more than 2 years, but we also have some very good examples of how quickly things can get done when there's a lot of interest and enthusiasm and push, and that's usually when what we're doing matters a lot.
So 2 quick closing comments. The first one being that these early allocations, unfortunately, especially for globally deployed things like BGP, those implementations stay in the field for years. Therefore, those code points are effectively dirty. It'll take a very long time before they can get reused. IANA is very good about not assigning that point until, as far as I know, most of them don't go back into service and haven't needed to. And again, the last comment is, as the people that are writing specifications, please help your coders make sure that these things are easy to do, make early deployment actually work. Thank you.
Thank you, Jeff. So now we're going to hear a presentation from the winner of this year's Advanced Networking Research Prize from the prize from the IETF. This is about central control over distributed routing.
Is that working?
Is this working, right? Hi, so I'm Olivier. I'm from UC Louvain in Belgium, and this is joint work with all these people. So we'll go a bit lower level on what's been said today, and we'll speak about routing and more specifically fibbing. So there's a pun, it's intended. So we want to allow routers to control their fib, and I'll walk you through to understand how we do that. If you take a simple network like this, we'll speak about intra-domain routing, so IGPs, and IGPs work by computing shortest path over a graph. So each router eventually manages to get this particular view of the network with the destination reachability information, in this case, just the blue prefix, and eventually compute the shortest path in order to route traffic in the network. You all know that. Let's get moving. IGPs imposes operators to do what we call descriptive network management. So from their requirements, they have to figure out how they want it to be implemented in the network. So if I want to do this particular security policies, well, I need to figure out, well, I want this in the network. Then how do I need to tune each router individually to do that for me? So that's a bit of a hurdle. And there's been a lot of research recently towards software-defined networking with other challenges. So in this case, we still want to play with IGPs. And so we've developed a technique that we call fibbing, which enables to do declarative network management. And so how do we do that? Well, we first of all let operators focus only on what they want. So they describe their requirements. They don't have to think at how to do it. We don't want to have the whole issues of scalability and other challenges that we had with OpenFlow P4 and this set of approaches. So we keep the IGPs themselves. So we still want to use distributed protocols for scalability, reliability, and so on. And so we have to actually play a bit with both paradigms, something centralized and something distributed. And so let's check how it works. So in fibbing, we have the operator specifying requirements to some centralized controller. Well, you could replicate it, but it's still one point of configuration for the whole network. So in this case, the operator wants to change the forwarding behavior in the network for the group prefix. So it asks it to the controller. And then we move to the distributed part. So what we call a fibbing controller is seen as a normal routers by the real devices in the network. So it maintains an IGP adjacency, an SPF adjacency with the others, and is able to exchange IGP messages. So LSPs, LSAs, depending on the protocol you have. So in this case, from the requirements, the controller computes some message to inject in order to implement the requirements. So in this case, this message is eventually flooded through the whole network. So that's a link state IGP. Everyone eventually builds the same shared view of the topology. And now we get to the interesting part. This message will augment the topology, will modify it. So in this case, this IGP message that we've injected adds one fake node, one fake router to the shared topology that announces also a route towards the group prefix. That's been linked to the router A with a particular cost, well shown as one. So if you look at this graph, and we'll get to the practical part, that's how we do it later, but just conceptually looking at that graph, if I compute a new set of shortest paths in the network, well, all of a sudden, the router A no longer uses the old path, so the one going from A to B to well, further down towards C, but all of a sudden it decides to prefer to use the path towards the fake node, so FA, because it's cheaper. So that's the resulting control plane decisions you have there. So you have A, the router A, that decides to select two different next stops depending on the destination prefix. So that's a behavior we're not supposed to have normally in traditional IGPs, just because these set of prefixes share the same egresses. So in this case, we are able to trick router A into believing, well, I would like to use that particular fake node. So that's nice in theory. In practice, we still need to forward traffic on physical interfaces, not fake abstraction somewhere in the software of the routers. And so we need some mapping function between this new information, the fake node, the node FA, and a physical interface, which is the third line of the IGP message, which literally maps the link from A to FA towards on a physical interface. So in this case, the link between A and router 1. So if you do that, well, you are able to get the data plane traffic flows that follow the requirements from the operator without touching the other prefixes in the network. So you are able to modify the path that are followed by the traffic on a per destination basis. So that's the high level idea on what we want to do with fibbing. We can do a bit more than that. So we've seen the case where we caused a single router to do a next stop change. So that's still what we have here. We caused the router A to change the next stop towards the group prefix. Well, if we want to compose complex path in the network, we just need to do that several times in a row. So for example, here, if I add a second fake node on the control plane, I'll cause the router 1 to also change its next stop. Eventually, I'll get to this set of paths that are chosen in the network, still only for the group prefix. I'm still not affecting the path that the red prefix uses. So the path that the traffic store, the red prefix follows. So that's the important part. We really have this expressive power where we modify selectively the behavior of the network without changing the protocol. Normally, at least that's what you would like to do. We've added a lot of stuff on the control plane. Well, in this case, it's a simple network, but figures if you want to run this on the network with hundreds, thousands of routers, it will hardly scale. So there's a way to optimize it, and that's what we have here. So if you play with the weights of the fake links and fake nodes that we distribute over the graph, we're able to minimize the number of extra information to add over there. So if you look on the right, well, with a particular weight set on the fake link that we have added, we're able to overall change the forwarding behavior of 2 routers at once on this sample network. We can get much better gains, obviously, at scale. So this reduction that I've presented before, we've implemented on some algorithms that we've benchmarked. So we basically are able to react to produce this set of augmented topology on ISP topologies that have like 300 routers and 2,000 links within milliseconds for the expensive one. So the one where we just implement the requirements, but with some overhead on the control plane. And we were able to reduce this topology, so limit the overhead to the minimum within a second. So it's fairly fast. So we are able to figure out how do we do what the operators want quite quickly. And so implicitly, we are also able to deal with failures quite quickly as well, because we are able to just adapt the behavior of the platform within milliseconds or earlier. So that's what we have. So we have this idea of, we have some centralized control for the operators, a central point of configuration that's easy to manage. We still keep the distributed aspect of the protocol. So we survive control of failures because, well, the routers are still able to control themselves. More than that, we're able to easily replicate the controller. Since it's just using the IGP graphs, well, it's automatically shared between every routers, including other replicas of the controller if we want to. And we also have some added benefits, like we support security policies requiring a fail open or fail close of the controller. So should this traffic still flow if the controller dies, for example, because it's no longer able to verify these security policies. Regarding what we can do with this, we've proved that we are able to implement any set of path that does not create a loop on a per destination basis. So what we call a per destination basis is an IP prefix. So I can change the forwarding behavior towards a whole /8 if I want, up to a full /128. So for a single host. So regardless of the prefix that we want, we will set up any path anywhere in the network quickly and efficiently. So these were the high-level idea. Well, let's see how we did this, because we implemented, that's how we benchmarked it, basically. So we are using SPF. Our controller is literally a virtual router that we can plug on physical routers. Because it's SPF, it's a link set protocol, we get the topology discovery for free just by listening to the LSAs and building the graph. So that's much easier to do than bootstrapping something like OpenFlow or P4, where you have to reinvent yet another topology discovery protocol. And we've been able to test it against Cisco devices and Juniper ones. Well, basically what we had. We sadly don't yet have Huawei hardware, but since we're following the specs, it should work as well. To get the feeling on how we did this, so if you take, in this case, the SPF v2 RFC, but for SPF v3, that's basically the same thing. For AS external LSAs, we have a field that's called the forwarding address, which is defined which enables to basically distribute route in the network without being yourself the IP next up. So it's better on that paragraph where literally you have a field on the LSA that's shown there where you can map a particular destination prefix, so the link set ID, to any IP next up, so the forwarding address field, with a particular metric. So if you do that, actually you are able to implement something that's very close to what we've seen before, which is this idea of adding stuff on the IGP graph, control plane graph, with a specific weight for a specific destination. You just have to play with these 3 fields. This comes with a small price, so we can approximate what we've seen before. So this idea of adding new information on the graph on a per prefix basis. We cannot really add a fake router. We are limited to adding fake links. So there's some algorithmic implication there. It doesn't work with RSIS. We've not found a similar feature on that protocol. So if we want to support it, well, we have to find something else. And there are rules within OSPF basically that govern how our routes compared. And in this case, we are limited and only able to control routes prefixes that have been advertised using type 507 LSS, so the AS external routes. So that's the limitation of the implementation that we have as of now, which works with current hardware. Obviously, we'd like to do something cleaner and more efficient, but we wanted a proof of concept. We've made measurements. So because we're using AS external routes, well, we have no impact on the shortest path computation on the routers. So we've made some tests with 100,000 fake nodes added on the graph, so 100,000 LSAs, and there were no measurable changes on the convergence time. Well, it's a vector addition, so it's normal. It's basically free on the super light on the RAM as well on the routers. Well, we're just storing LSAs. Again, that's a super small structure. It's very optimal. And then we have this huge benefit that, well, you're familiar with, which is the fact that pushing a route to the fib, at least in current hardware on routers, is quite fast. And this figure there is quite important because, for example, when you play with OpenFlow switches, it can take up to 2 seconds to push one single route in the fib. So that's a huge improvement if you want to change the forwarding behavior of the network quickly. We've seen the idea behind fibbing. We've seen how we implemented it. Well, let's see what we can do with it. So one simple example in this case. So we'll still use the same network topology, the same set of weights. And if you remember the shortest path sets that we had before, by default, AB will be routed through to router 2 towards router C. So they will all take the middle path, the central one. So if you take some network under some circumstance, you could have a case where you have a lot of clients all of a sudden hidden behind the prefix that start to exchange a lot of traffic with servers that could be attached to router A and B. So if you do that with this set of weights, well, you have a bottleneck on the network. So you're using just the central path and all the other links are unused. Eventually, you can congest the network. Well, that would be a bit extreme, but that's the idea. We are using too few resources, well, less than what we could have in the first place. So fibbing lets us program paths, so change forwarding behavior, but we also control the cost. So in this case, I could add a fake router on the graph with a particular cost. And if you compute the spanning tree that you get by doing this on the graph, you see that router B now sees 2 different paths towards the prefix. The one directly throughout the fake node with a cost of 2, and the original one. So if you see this on the control plane, well, on the data plane, Link said that GPU support is simply natively, and that's what happens here. We are able to program on-demand ECMP on a per destination prefix still. So if we add another prefix on router C, so if we think about the red one that we had before, the red one would still only use the central path and not use the newly created one that enables to split the blue flows. We can do a bit more than that in this case. We're still not using the left set of links. So we can add yet another equal cost path. So if you look at router A, it sees 2 different paths with a cost of 3 towards the blue prefix. And we can do even much better than that. So if you look at the link utilization ratio we have, we are still not really using the left part of the graph optimally. We could add some more load over there to, well, average out the link utilization in the network. And that's what we can do by adding a 3rd fake node on router A that will add a 3rd available route seen by router A, with the added trick that these new fake nodes use the same underlying physical link towards router 1, which causes router A to split traffic with a 2/3, 1/3 ratio between the 2 physical next stops. And so we're able to average out the link utilization load in the network. Yes?
Hannes Gradler, Rtgarea. There is actually two existing solutions for that problem, right? The first one is called forwarding adjacencies, where you advertise a RSVP tunnel, right, in order to take some traffic path control. And the other one is called segment routing, which also very elegantly would support the indirection issues that you have seen in the OSPF and ISIS protocols, right? Rather than, plumbing together the control plane path, you could actually do the mapping when on the RIP calculation code path and producing a stack of node labels. I mean, have you looked at those alternatives? And is there anything that you didn't like about the existing approaches?
So we've played with segment routing, and there's one thing that we disliked a bit was the fact that with segment routing, you still have to literally configure the ingress of the segment routed path. And so if you want to program, 100 routers at the same time or 10 routers at the same time, you still have to do 10 configuration steps for the controller. And at least on the research part, there's some scalability challenge there. But yes, you could do something similar by plumbing segment routing or MPLS and RFSP-PTE, or, you certainly could reuse a lot of the existing technology altogether to solve one particular use case, certainly.
So you're talking about doing lots of upgrades.
I'm sorry?
You're talking about doing lots of these, then you presumably don't want to glitch your traffic, and so you need to also run loop-free reconversions on some of these, because if you change those in the wrong order, then you're going to, the cure is worse than the disease, right? So, but you don't get that problem with segment routing. Segment routing will never cause a loop. I think this will cause loops.
We can compute the ordering, actually, into which we can inject the fake nodes.
As soon as you're doing that, you start to lose all the advantage of doing this, and certainly you lose the put it there in a few milliseconds approach.
Yes, that's correct.
So if I can remind people to introduce themselves, I think this is Olivier's first IETF, so he doesn't know everyone. Neither does everyone else.
Just sincere. So, leaving a CMP aside, any traffic going towards particular destination will follow a new path. So I think it would be really interesting, since you are mentioning traffic engineering, and traffic engineering value when you can use different classes of traffic going towards destination using different topologies. So have you looked into how to divide, so not only being destination driven, but maybe provide source destination or some other type of mapping of fact to destination to the topology?
Yes. So currently, if we stick with the implementation we have, AS external LSAs enables you to give different forwarding addresses and metrics based on the TOS byte on the traffic class. So there's one there. So we could program a different path for the same prefix depending on the TOS class, the type of service. There's also the alternative, which is we are here programming paths with a given cost. If you use an overlaying protocol such as LDP with MPLS, while you encapsulate whatever you want with the right label, and we control the distribution of the label throughout the whole network. So
maybe source destination could provide.
Yes. We've implemented the last example, and so we've run a sample testbed where we had over time an increasing number of clients appearing behind D1 and D2 and starting to request data from servers located behind S1 and S2. And so the following graph show you the link utilization over time of the 3 different paths. And basically what you see there is that as the demand from the clients behind the router C increases up to, in our cases, close to congestion, the controller is able to dynamically add these equal cost paths that we covered before to decrease the link load utilization. And so that's what you see at roughly the 30 flows mark, where you have this huge drop in the red link utilization because all of a sudden B starts to do equal cost multipath routing over the two available paths. And that's also the result of the third drop, where all of a sudden you have this huge green spike because A is starting to send twice as much traffic towards over the green path than on the other path, the other one. I've mentioned an even load balancing. So in this case, it's a simple example with 1/3, 2/3 ratios. We are able basically to do any set of fractional splitting combination. And there's a paper at Connect next month that covers how to do this set of real-time traffic engineering to reach optimal link utilization within milliseconds. Yes.
AC Lindo, how do you, I know you create the fake node. How do you get the bidirectional check to the real node that you have the fake link in?
So there's no bidirectional check because we are not able to craft router LSAs. We have to inject ES external LSAs. So we're literally plugging routes. And so in this case, we.
So you see, but what router ID do you use in this picture? Say for the fake node A.
Yeah. So that's a very good comment, actually.
Yes.
So there's a lot of engineering behind within the controller itself because we have to multiplex there and show the controller as a fake, let's say, LAN area where you have different routers to provision different router ID. And we basically need one router ID per fake node on towards a destination.
I can see you have that, but how do you get it how do you get the fake, all these fake router IDs, how do you get them reachable within the topology?
We maintain an adjacency, so we've.
Oh, you actually create a fake adjacency too.
Yeah, it's a real one actually. The one we used to. So this one.
Oh, okay, and that does all the fake ones.
So we are literally plugged to a router. We listen to everything and participate to the topology, even though we don't announce any prefix and are never used.
So you have to use you have to use type 1 metrics in the 5 and 7, and you have to, okay, I can see how it could work. And you could use one, I mean, a fake adjacency. You could put it anywhere you want in the topology.
Yes, and we can control anyone.
Yes, by that. But you have to make sure it's all type 1 metrics, and that the type 1 metric for all these prefixes for the normal path is at least 2.
Yes, exactly.
Yes.
That's a very good comment.
I've looked at OSPF 1 or 2 times.
That I know, but we had to basically discover all these knobs to make it work. So it's good to see that you people could have done it much quickly. But
so Stuart Bryant again. So a couple of things. Have you looked at how well this compares to a simpler approach of using downstream routes or LFAs as an alternative? They were originally invented before we even thought of fast reroute and are in the original ISIS spec. So it would be, you really ought to compare this quite complex approach with how much you would get by using this very old method. Secondly, you really ought to, you might want to look, so saying have you looked at this on some real topologies? I mean, it's very easy to generate a set of properties on small systems like this, but we found that when we were doing the fast reroute work, that looking at real provider technologies gave you a whole load of different insights as to what's going on. And thirdly, Russ White was pointing out that a technique that was published here to do incremental metrics, isn't it? Yeah, incremental. Orders fib, that's what it's called. Orders fib is a way of controlling this, the introduction and the removal of these in a way that doesn't generate loops.
Yes, so the order fib approach is with Pierre-François, I think, which is, well, I think he was part of that work or someone like this. So we know the one that made them because used to work with us. There was the LFA. So you mentioned LFA. As far as I understand, LFA is used in OSPF for fast reroute and in EIGRP to do load balancing already, right?
I don't know if it's used in EIGRP. Alvaro would know more than I would, but yeah, really it was used for fast reroute because that was the kind of the first sort of practical application that people thought of, even though it was invented back in the 80s. But it would work just as well for this to some degree, and it requires no protocol work to be done, and it was actually invented for exactly that purpose.
Yes. So the issue we had with LFAs when we looked at them was that we had no, or at least we did not understand how to explicitly control the path that would be chosen. So in this case, I've got an example where I just want to split traffic. If I want to combine this with a specific path to be followed and make this happen only under failure condition, then all of a sudden we.
So it is quite hard to do multiple concatenated LFAs, although Aliyah did some work on something very similar in fast reroute. But quite frankly, as soon as you get beyond one or two hops of it, segment routing is a much easier technology, and again, is no additional state in the network.
You mentioned the second comment, which I tried. So there was LFA, ordered fib.
Ordered fib, LFA, real topologies.
Yes. So we did simulation on real topologies. Well, mostly the one inferred by the rocket fuel project about 10 years ago. So that's a few hundred routers and few thousands of links. And so we were able there to measure the fact that we are able to optimize really efficiently the topologies that we generate, so to minimize the number of messages and state that needs to be injected in the network. And yeah, from there we basically try to measure how expensive it would be to change the next hop of, let's say, 50% of the routers, and it turned out to be actually quite low, because these topologies are quite connected.
So just picking up one thing from Russ again, have you looked at non-planar topologies?
I'm sorry?
Have you looked at non-planar topologies?
Not so sure what you mean by non-planar.
Well, a cube or a sphere or...
Yes, we looked at them.
Okay, good.
And yeah, your last comment was on segment routing, that there's no state in the network. Well, yes, I guess that it depends on the trade-off you want to make. If you have some long-lived forwarding state that you want to inject in the network, whether you want to tag every packet with it or touch once the control plane and leave it as is.
So be careful here, right? The selling point is that you can do short-lived things with this. Yes. That is inconsistent with the need to make sure that you don't cause microloops to occur. And microloops, we know, take a long time to manage out of the network. So I think you've got it completely the wrong way around. Ordered LFA, not LFA, segment routing allows you to put something in very quickly and get rid of it very quickly, and nothing bad to happen to the packet. The technique you've got here risks doing collateral damage to the traffic, particularly if you try and do it quickly, which means that you can't use a loop prevention technique.
So we need to move on a second. After Robert, we're going to stop questions. Olivia is going to be here at least the rest of the week. Yes, so we can talk to him the rest of the week. Thank you.
Robert Rasho, quick question. So I can see how it can work with IP routed network, but if you have LDP network, how do you actually inject remote labels into your fictional nodes?
So LDP follows, the LDP labels are propagated following the shortest path, determined by, chosen by the IGP. So we basically route specifically a particular IP over the network. Then you start, fire up LDP that propagates the label along that path, and you just need the ingresses to push the MPLS label.
You're assuming Okay, so you're assuming the label is already there, and you're just modifying which direction the packet flows with the label, which is already there.
Yeah, well, there's some coordination to have at the controller level, which label should be mapped to what IB. But yeah, that's a good point. Well, we're running out of time, but that's nice because it's the last slide. So we've had a few points to make after this work. So we've basically seen that we're able to do quite a lot of stuff directly within the IGP. So we are able to do real-time traffic engineering, which is something which was rather hard to do with just IGPs. Yes, you can mix a lot of other protocols in it, but well, we wanted to minimize the protocol stacks. We have no impact on the data plane, so it basically works as is. So we don't have to change routers to support some other types of encapsulation or protocol or whatever. We're starting to look at the effect we have on BGP specifically, because we're changing paths and costs, and the IGP cost is one of the decision criteria within BGP. So we are actually able to shift transit traffic through the intra-domain routing protocol and have a fine-grained control over it, but that's already work. And we believe being able to specify exceptions within the control plane like this simplifies the underlying basic configuration of the IGPs themselves. If you don't have to compute super complex weight matrices to make all your policies on the network and just route the 3 problematic flows, it should help operators at least to simplify the stack. With that said, well, there were already a lot of questions, but if there are any more, and if we still have time.
No, we don't have time. Thank you so much. Again, Olivier and his team were the winners of the recent Applied Networking Research Prize from the IRTF. He's going to be here all week, so you can ask him anything you want the rest of the week. Thank you so much. So now we're going to go into the long-awaited and always liked, fascinating reports. We're going to start with the Routing Directorate report. So Jonathan here. Here you go. Hey.
Okay. Is this on? Yep. Okay. So just quick recap of the Routing Directorate. There's a panel of routing experts appointed by the ADs, 47 people currently serving in the directorate. And the tasks they do, basically reviewing IETF drafts at IETF last call, providing feedback on those, both within the routing area and also drafts from outside the routing area that have significance for routing. Doing quality assurance reviews for documents within the working groups, so before they reach the IESG, that's by special request. So if you're a working group chair, then you can contact any of the secretaries that were on the front slide there and ask for your draft to get reviewed, and we'll find someone to do it. And these reviews are assigned out to the directorate using a round-robin algorithm, largely. So occasionally there'll be special cases where we'll handpick a reviewer, but by and large, a draft will just be assigned to the next available reviewer, and they will review it and provide the feedback. One other job the directorate does is assisting the ADs in making judgment calls from time to time, and you can read more about it, or all about it, on the wiki. Just a few stats on what the directorate did during 2016. There were 87 total document reviews. It was fairly non-even in terms of when those reviews happened. Quite a lot happened before IETF 96. Not so many before this IETF, but I think in general, the workload is split reasonably evenly between what the ADs are asking us to do and what the working group chairs are asking us to do, which is kind of surprising because I think there's a lot more work going on in the working groups at any one time than the ADs have on their plates, but I think that's kind of more because people in the working groups aren't yet quite used to asking for the QA reviews. So if you look at the breakdown per working group of where the reviews are coming from, it's fairly evenly low level with a few prominent spikes amongst the working groups that have really seized on their opportunity to get their documents reviewed. So Trills had a field day and had 20 odd reviews done. Other working groups haven't had taken quite so much advantage. So I think there's scope for the directorate to do more work. At 8 to 7 reviews in 2016, that's about 2 reviews per directorate member. I think they could handle more. So if you want to get more value from the directorate for your working groups, then please let me know. Okay. Any questions or comments? Okay, thanks.
Thanks, John.
And also, John, thank you. And also John Hudson and Jean Chang, who's not here, for all of your work in handling the reviews in the directorate. It's really appreciated. And it's the kind of work that's behind the scenes, and we don't thank you enough.
You're very welcome.
Okay, so now we're going to start, as I said, the much awaited and often enjoyed working group reports, starting with Babel.
So Babel's meeting the last slot during the week. It really says there all there is to say. We're working on currently moving the Babel protocol documents from experimental to standards track, and have some presentations on some TLV details, which seem highly relevant to the charter goals, and beer in Babel, which doesn't actually seem to be in the charter, but hey, we have the time, so that's about it.
Okay, Mark.
Martin from BES. We met yesterday. Sorry, I can't read myself. We have new BGP-based work coming up that will lead to interesting discussions with other working groups like SFC, but also Spring, TIS, and possibly IDR. EVPN is still the biggest piece of our work, and we still have some MVPN, but this is just to test Alvaro's capability to convince the IESG.
Thank you. Yes.
You're welcome. Well, yeah, that's it. One URC, 2 working group last calls. And we're trying to finish, well, we have a chance of a bit of work to do, 6 stock in our queue, and we're trying to close down on the MIBs. We're struggling a bit here, but we might have found a way out. Thanks.
BFD is not meeting. We have no progress since last time. We have a very small amount of lingering items that we're trying to close off, and we're going to hibernation after that.
Beer, anyone? Beer, Aliyah, I'll let you talk to Beer.
Beer met yesterday. They had a fine meeting. They continued, they're planning on consolidating after the interim meeting. They had the Ethernet and the MPLS encapsulations. There continues to be active discussion about the idea of doing a V6 encapsulation as well, and they're talking about bringing some of those ideas to 6-man. And that's basically it.
Daniele for CCamp. We have two sessions at this time. One was yesterday. It was a joint session together with the TIS, MPLS, and PCE to discuss about everything that is young and T related. We will meet with the CCamp only staff on Thursday. From the highlights point of view, actually, we have 2 design teams. One for microwave that is moving on pretty fast and pretty well on the definition of a framework for the management of microwave networks, and we have the first young model available. And the second design team was created just yesterday, the day before yesterday. It is a design team aiming at the definition of a northbound interface for transport controllers. We had 19 volunteers for the design team, which is awful. We are extremely happy about that. It will be a work pretty tightly connected with what TIS is doing. So again, a coordination with TIS. What else? We have a draft that is, we decided to stop. Deborah sent it back to us because there were two options to progress the draft. One was a specific solution. The second one was a generalized one. We decided for the second one, so we have now a draft in TIS to define a generalized solution that this draft will use for a specific usage. Summary, we have a new RFC, 7963, RSVPT extensions for additional signal types for G709 OTN networks. One is the draft that I was speaking about before, SPF availability extensions. One in last call, and as usual, a pretty intense liaison relationship with ITUT. This time it is about study group 15 OTN standardization work plan and updates.
Okay, DetNet, they couldn't be here. Overall, the working group's going pretty good. It's considered it's a new working group. They adopted their data plane alternatives draft. And there's no fear here. They're not creating a new data plane. They're probably going to use pseudowire over MPLS or IP. And they're starting work on their information model.
Hi, I'm IDR. IDR, IDR. I'm both, Jen's going to do IDR, I'm going to do I2RS. I2RS canceled its first session. We'd held it because we'd thought we might yet do another fun round of protocol requirements, but thanks to our loving AD, we have passed that bar and are heading down to the joy of data models at last. So that's really good. So we've got two data models that are off to the ISG shortly, and they're the topology data models, which Benoit's little diagram shows us in the center of the world. Oh, cool. Secondly, we're going to go through some of the other data models, just some comments and review. Our real next step is to get implementations of these data models based on public code so we can figure out if they're reasonable. One other side bulletin, as I was in the NetMod working group, is I believe they are making appropriate progress on the op state, and for I2S will probably, because they're making some good progress, pick up our old discussion of caching between two agents, just because they've made some good progress. So if you're interested, if that was a topic you thought was off and you're interested, like Russ might be, just come and see.
Hey, John Scudder talking about IDR. So over the last, well, since the last meeting, we've had a interesting exercise in progressing documents in a less stately fashion than our normal custom. And we're pretty close to having a document ready to send you guys. So one meeting cycle is, I think, a record for our group. You've already heard Jeff's talk on code point squatting. We were the ones who got to experience the brunt of that and are still doing some cleanup, and we'll probably be continuing to do that for another meeting cycle at least, and we'll be talking about that in our meeting, which is in the next slot. part of the cleanup has been, we've been requesting early allocations left and right, relatively speaking. One piece of feedback, I mean, this is something that hopefully everyone in this room already knows, but I'm just going to, and Jeff already said it, but I'll just say it one more time, which is requesting early allocations is easy and painless and makes your life easier later. And I'm not going to try to summarize the agenda. It's linked there. And I think I won't read you our list of status either. If you have any questions, feel free to ask. We have one working group last call. It says complete, but large communities. We had a few additions that seemed like they were worth validating on the list before we called the working group last call completely complete. So one more week worth of that. And as we are infamous for, we like things to be implemented before we standardize them mostly. So we have a couple of things sitting around waiting for implementations. Final point is sometimes we even kill drafts instead of advancing them. So down there at the bottom of the screen is one that was overtaken by events. Large community does the job that generic subtype for blah, blah, blah was supposed to do. So we, at the author's suggestion, are going to move to kill the generic subtype one. That's all.
ISAS, this is one of Alia's favorite pet projects, right? So trying to make ISIS and OSPF conduct a joint meeting. This time we'll meet on Wednesday, just after the OSPF working group, and trying to figure out how much actual overlap we have between the two IGPs and cut down on meeting time for protocol extensions like geolock that applies to both protocols. Apart from that, not much controversial going on. Interesting thing again for both OSPF and ISAS is advertising TE protocols. There's been made the observation that over the time people are advertising different sets of TE TLVs, and it's today really unclear whether actual RSVP protocol has been enabled on a link or not, just because, you know, the link bandwidth TLV is there, doesn't say anything. Apart from that, we're trying to close down on segment routing, put that to RFC track, and also ISIS Young models are being discussed, where Stefan has posted both the basic model and the SR extension for that. Two new RFCs. Second one, RFC 7987, is particularly interesting because still after, you know, the protocol being in operation for more than 25 years, so still bugs of the base specification, not necessarily the IP part, are being discovered and fixed here. Furthermore, a hole is being closed in segment routing, which is to advertise how much depth of labeling positioning can be done on an actual node, actual link. Okay, that's it.
Okay, on L2 TPXT, they are not meeting here. They've been, they finished their IPv6 document, and it currently needs a revised ID. When I went through the ISG, there was a discuss, and so they're busy with that. And they have one other document that they hope to do yet, and that's the Yang model. So that's where they're at.
Luigi for Lisp. So we will meet tomorrow morning. The latest news are we have 2 new RFCs, as we can see over there. Basically, Ayana has reserved a new IP address, IPv6 address block to be used as the EID prefix. Okay, RIPE NCC will manage this address block. This is just a temporary allocation for a few years. Then we have 2 documents in the RFC editor queue. We're just waiting for missing references. 2 are under discussions in the ISG, namely are the DDT, which is the one is the, let's say, the one kind of mapping system, and the LCAF is the Lisp canonical address format. Okay, so there are a few issues to be solved. Okay. In the meantime, we have another document that just passed the working group last call. So we push this asking for publication, which is a small document that defines some experimental messages format and asks Ayana to create a registry for code points for these messages. Okay. Big chunk of work is ahead of us in the sense that we have to create the 6830 and 6833 bis, which are the main specs of Lisp, which are these 2 RFCs are experimental. We have to review them in order to make it standard track. Okay, so and this will be the big discussion that we will have tomorrow. And then we have one last document, LispSec, which is about security of the mapping system. I think we are close to working to last call. We reviewed the documents, the authors are updating it, so pretty done on that one.
Neither Justin nor Stan could make it out to Korea this time, but the working group Manet is meeting tomorrow morning. Rick Taylor, who's one of the working group participants, is going to be chairing the meeting for us. Most of the work right now is on DLEP. DLEP, if you guys came to the routing area meeting last time, you might remember this is the dynamic link exchange protocol, which is right now in IETF last call. If anyone of you want to go read the draft, please go and read it. So most of the work is extensions to DLEP.
So MPLS, there's a new working group chair. I guess that's me. Being the new chair and new guy, I'm also the winner of our internal Who Gives the Update present competition. So there are 2 new RFCs. LSP ping being 4379 is approved by the ISG. And there's a lot of work and progress around the young models. And we do expect that we have the first young models in working group last call before the next IETF in Chicago. That's likely to be in the base model, I guess. And that's all. Oh, the meeting, and by the way, the meeting is on Thursday at 3:20 p.m.
Okay, NVO3, I'm Matthew Bocci. We're meeting twice this week. First time it will be tomorrow afternoon. So the highlights are as you may know, we have 3 data plane encapsulation drafts in the working group, which the working group can't form consensus around progressing one of them. So we formed a design team to try and progress data plane encapsulation work with an initial draft expected by the next IETF. We held an interim to discuss the issues around the data plane encapsulation and its design team at the end of October. And we're also going to try a bit of an experiment at IETF 7 this week. And we're going to have some roundtable sessions in the first meeting to try and discuss some of the broader issues around control plane and OEM related works, particularly in the working group, and try and stimulate some drafts in those areas. So just a little update on the working group status. Our architecture draft is with the RFC editor now, or in the RFC editor's queue, and we have a multicast framework document waiting right up from me. Thank you.
AC Lindem, OSPF. We're meeting tomorrow at 9:30 in the same room as ISIS. One thing we've done in the spirit of consolidation is we have some controversial items on the agenda, and we've moved geolocation to last. So if we don't get to it, we'll have the presenter present both ISIS and OSPF together in the ISIS slot during that time, because they're for that particular topic, they are very similar. You can see we have I'd say the biggest highlight is the Yang model. We're trying to get to working group last call, and the biggest controversy is the link attribute encoding debate that we're going to have tomorrow, and that's about it. Status: we've had just one. We have one RFC published and one close to being published. That's it. Oh, we're still looking for OSVF v3 extended LSA implementations, which would be a good topic for these research groups as well.
So PALS didn't meet this time. We've made progress on 2 of our drafts, which are either a new RFC or with the RFC editor. We have 4 of our drafts with Deborah and colleagues at the front, either in expert review or AD evaluation. 1 draft, and it's been a bit of a plea for people to actually read this draft. Point-to-point pseudo wires is in working group last call. I don't think I've seen any discussion on it on the list. But there's a point of note with that draft, and that's that it took me a long time to get through the IPR sign-off. And that's because there were so many, it's quite an old draft, there's so many authors, and one of them I still haven't managed to track down. So the moral of the story is think very carefully about how many authors there are for a draft. All authors who contribute text obviously need to be there, but there's a downside to putting additional authors on the front. But that caused me to think of something else, which we should discuss as an area, which is the practice is to do an IPR call on all of the authors. But shouldn't we actually be doing it on all of the authors plus all the contributors?
Yes, we should.
No. So the call that we do for IPR is a reminder to everyone of what is said in the note well at every single meeting, which is you need to declare your IPR. It's a courtesy to the authors. If we try to include all the contributors as well, then we end up in a much longer state. And it's a courtesy reminder that adding extra process there, I think, is more painful and would add worse delays.
Well, I think probably this needs a longer discussion actually, because IPR does come out of those, and it's intended as much as anything to stop embarrassment and stop people implementing stuff that's got IPR in it without knowing it.
Yes. So can we take this to the list for now? And yes, we need to discuss that further.
Just a quick comment on what Elias said. We had the practice of doing IPR calls, including the contributors, and we have no indication that it actually takes longer time.
Okay.
Okay, PCE.
So PCE's meeting twice. We already met on Monday with CCAMP and TEAS and MPLS to talk about Yang. We're meeting again on Wednesday afternoon, session 1. Highlights from PCE, lots of work going on stateful PCE. The base protocol is I'm reliably informed, one last revision and 1 week away from being submitted for publication, and then we have a lot of new tools being added to the Stateful PCE toolkit coming on top of that. So lots of work on Stateful PCE. We're making good progress on the Yang model, and we have several new work items being discussed this week, including PCE as the central controller for a network and PCE's role in ACTN. A quick summary of working group status. We have no new RFCs. We have 2 documents lodged in the RFC editor queue. The Stateful PC applicability statement will be our first Stateful PC RFC, and we're all pretty pleased about that. And we also have the service-aware PCEP extensions, which are waiting for the base PCE protocol before they can be published. We have 2 documents of past working group last call. There's the inter-layer extensions and the inter-area, inter-AS applicability statement. That's it.
So Stig and Mike couldn't make it to this meeting. Pim did meet on Monday morning. This was a joint meeting with MBOND. There's been quite significant progress in the last few months on the Yang models. We're ready to move the ping Yang model. We also have IGMP, MLD, etc. There are some dependencies that we need to clear up with BFD, actually, in the PIM model, but we're moving along.
Peter for all. One of the nice things is that the last of our applicability drafts is going to be concluded. We are very grateful for the work that has been done here, and the supporting applicability. How do you call it? I have this lapses of memory. Sometimes the supporting draft, which always gave the template for this applicability drafts, will slowly fade away. We have the routing dispatch, which we inherited from 6 law, which is approved, so we think that will terminate correctly. There's another document in 6 law, which is also all completing. The use of RPL info is in working group last call. That is about how you have packets which go into a role-oriented network and then leaves out it, and what kind of headers you have to add and remove at which moments, which is a rather complex process, and which is very well explained. And the last thing is we seem to have reached consensus on our charter, and hope that very shortly we will be living according to the charter. Goodbye, thanks.
Routing, we are meeting twice, once today morning and once Friday. So great progress on routing and architecture design team. We are moving from definition of what data models are to consumability, how to use them, how different data models work together, so people can use them. We are continuing work on FRR topics, which is central work of routing working group. Status, we don't have new RFCs. Keychain draft has to go through additional updates. It already passed working group last call, and we'll send it to ISG soon. There are 2 more stable Yang drafts which are ready for working group last call, which we'll initiate soon, and it's pretty much it.
SFC met Monday morning. There was an interim meeting in mid-October, which had a bunch of useful discussions, but we're trying to resolve a lot of the open issues. We obviously don't have any new RFCs. We're working on the control plane draft. I'm meeting with Aaliyah later to discuss some of the issues that the AD has with that. We've had a lot of good discussion on the list about NSH. We are trying to wrap that one up. And there's a lot of interest in moving the other work, such as the OAM work, forward, and people are working on the TLV drafts. We've had good discussion and good engagement. We have to drive that to completion. That's what we're trying to do.
Sandy's not here in Korea, and Chris couldn't make it to the meeting. CIDR is meeting on Thursday, probably for the last time. We're going to close CIDR very soon. All the work is finished from the working group. Most of it is sitting in my queue. So I'm the bottleneck right now. We have some documents in IETF last call. We hope to get BGPsec done by the end of the year and publish early next year. CIDR is being closed, again, because the protocol work is done, but we're chartering a new working group that has already been approved by the ASG called CIDR Ops, with the hope that as origin validation and BGPsec get deployed, now we have operational experience and we can continue the work there. This time, we're already talking about operational issues, of course, and next time in Chicago, CIDR won't exist and CIDR Ops will be the one meeting from then over.
Martin from Spring, we are meeting Thursday. Working group is focused on delivering the architecture and the 3 use cases. But to not echo, but respond to Laura, we have some issues in the working group with regard to IPR polls. Well, there are a bunch of them which have been running for 3 months, and we still don't have all the answers. So as a result of that, we have kind of a progress issue in the working group. No new RFC, 2 out of 7 working group last calls effectively completed, and 1 out of 3 adoptions completed. So we're working on a roadmap, quite aggressive one for sorting out the situation and present something much better in Chicago.
On Biram Fortis. We met twice yesterday. We had the regular session in the morning and a joint Yang session at CCAM, MPLS, and PC later in the day. In terms of highlights, the modeling work is progressing quite well. The base features in all the models are sufficiently baked, so the next goal would be to see if we can take the base versions to last call quickly. The ACTN work is also progressing quite well. In addition to the requirements and framework documents, we have a few individual drafts that are focusing on solution aspects. We also recently adopted an architecture document for PC central control, and we are currently discussing use cases. In terms of document status, we have 1 new RFC, 1 that's in the RFC ATS queue, a couple for which we recently put in publication requests, and we also had 2 new working group adoptions. That's all I have.
I got it, Donald, thanks. One really good thing about the current status is Trill is actually seeing some deployment in data centers, and so some of the issues regarding group keying, shifts in tree structure, and path telemetry come out of that. Since there are operational issues, we're trying to deal with them, and then we'll talk to the AD about the next steps. It's good to have deployment.
Thank you. I hope everyone enjoyed the updates as much as we did up here. Thank you for staying the extra couple of minutes. And if you have the blue sheets, please bring them over. We'll see everyone in Chicago. Thank you.
Yes. Where should we have that discussion on contributors versus on which